so you could go and interact with them, get to know more about what you want to do. But also the very location of King's and the work culture of universities in the UK is such that once our classes would end in the evening, you can go and go to a lot of networking events, workshops happening all across the city, and you can start working towards what you wish to do starting now. And there's like a very huge internship culture abroad, so you can start getting involved in that. Also, King's has upwards of like 300 societies, so I'm member to like 12 of them, and I'm on the committee of 3 out of 4 of our department societies. I'm president of Space Society, which has got me in contact with UKSEDS, which is UK Students for Exploration and Development of Space, which is this organization which organizes a lot of events for students and space sector, bridging this gap. And I'm a volunteer for 3 of its teams, which is a great opportunity I came across through the society membership and presidentship of the branch of UKSEDS. I'm aware that there's an India branch of UKSEDS as well. So so this was the society aspect of it, but societies also give you this platform to network with people, meet people, but there's also a very formal side of it where you can learn a lot of skills which you might not be learning as part of your curriculum. Like I was part of a robotics society last year, and they emphasized on us wanting to learn about Arduino and AutoCAD, and I learned it for making a mini Mars rover, etc. And then you go, so later when I started researching into the kind of skills I require for an aerospace engineer, I realized how AutoCAD is a really important thing for that. So learning in an environment where you have some core modules as part of your curriculum, and then you also have a lot of societies where you're learning things in a very friendly environment, it's just like a good way to learn things without reaching a stage of a burnout, which is definitely something I love a lot about King's, which I can't really say about boards, because I remember when I was at school, there was so much pressure and a lot of people did reach like a burnout stage. And I feel that wasn't the case at university.
Wow, that is different. Because some people tell you that, it's just going to go downhill and now it's going to become worse. But if we get the assurance from someone like you telling us that it will get better, then that is amazing. Okay. So, how do you think STEM will progress in the coming years?
I feel like humanity as civilization that it is has moved from one stage to the other on the basis of STEM developments. And that has been the case, that will be the case. And change I see in this industry is definitely a lot more emphasis on diversity and inclusion, and a lot of people coming in and advancing this STEM even more. Obviously, this century will see a lot of emergence of a lot of new fields in STEM, like the emphasis that we have on biotechnologies, food production, engineering, and interplanetary travel, which is definitely something I wish to go on to work in, AI, robotics, quantum technologies, and so on. And definitely these are things that STEM will entail in the coming years.
Yes.
Yeah.
Okay.
So that's how I see it progressing in the coming years.
Yes, great. That is wonderful. So, so we are glad that we have someone like you can explain to us what theoretical physics is, to tell us that it's important to, choose a proper division even when you're studying physics. But how did you figure out that theoretical physics was the right thing that you wanted to study?
I think theoretical physics by its very nature has been one of the cornerstones of modern science, and everything that we know today of technology has started off with theorizing it, and so much of the technology around us has its basis in physics. All technology relies on laws of nature, and a more fundamental understanding of our nature will help us to develop these technologies much more and help us make more powerful technologies for future. Well, everyone knows about the example of how electricity and magnetism came and got combined by Maxwell into electromagnetism to make the electric motor generator, safe power distribution mechanisms, etc. and then it was further worked upon by Marconi, which led to the era of communications, etc. But this is me just trying to explain to you why theoretical physics can be applied, but applied physics is not the reason I chose to study theoretical physics. I understand the need to finding use for a subject you do. So that's why I wish to go on to work in aerospace engineering, which is a much more applied form. But the reason I do physics is because I actually enjoy it. And one thing I would really, really like to stress upon is when you're at school, you will be taught, at least in CBSE, how our system worked was you are given a certain set of questions and you're told how to solve them, and you're not exactly using analytical skills to model a system on the spot in the exam and working on that. So you never really quite get to love the subject. So I feel like even back at school, the reason I loved physics was because I spent a lot of time on YouTube, etc., watching a lot of astronomy videos, physics videos, and well, you see the essence of physics, and that is what draws you to it. So whatever field it is, right, I really feel you need to branch out beyond just what you're taught as part of your curriculum. So the reason I like physics is because I like answering a more philosophical bent of questions out there, like why we exist, why we here, what is our planetary neighborhood, etc. And well, people could be drawn to the philosophy side of it, and I like a more exact, a more objective analysis of this in a more mathematical sense. And I was just automatically drawn to physics. And you can see how mathematics is bigger than our universe because you have infinite possibilities in mathematics. But when you have a certain possibility and you connect it to what is experimentally observed, now that is the stream that you're talking about, which is physics, which is very interesting in itself because you're understanding the way the world is coded in. So I think I love physics because of its more philosophical bent, but not exactly for a very, a very applied basis of it, which of course exists. So if you want to work in that, is great as well.
Yes, makes sense. Okay, so this will be my last question. And I just want all the audience members to know that you guys can, type down your questions in the chat box, or you could raise your hand once ma'am is done finishing off answering this question. So the last question is, any final piece of advice you would like to give us budding girls in STEM?
I feel one thing, when I'm talking to all my friends who are still studying in India, I think there's not enough emphasis on coding, because when you have any research or work opportunities abroad, in literally any stream of STEM you can think of, they're going to emphasize a lot on your coding skills. And you can look up what coding skills are most relevant to your stream. Like for me, MATLAB, Python, AutoCAD, these things are really relevant. So I spend a lot of time trying to learn them and understand it better. But this is definitely something you need to stress upon, because when you're working in a global scenario, these things will count. Other than that, I feel I was very lucky to have never faced gender discrimination based on the fact that I was a woman, and the fact that people would feel that I couldn't do well in STEM. And I'm very lucky to have been at such a place. So anyone out there who feels like this is their case, remember that I don't feel at any stage that I'm lesser than a man, not just because of my conditioning, but also the way I'm working in my field, the opportunities I see. It's no matter what conditioning you get, you can do this. And these stereotypes exist, but like, I do not feel like there is a gender divide between subjects. Like, though I see a larger percentage of women in biology, chemistry, whereas in physics, mathematics, you have more men. But I don't feel that should be the case, and you should definitely try it if you really enjoy it.
All right, that is wonderful. Okay, so we have one question from one of our audience members. Can you tell us about your work as a theoretical physicist?
Currently, I'm an undergraduate student, so I can talk about what we are studying. I can talk about things I'm writing. So I'm working with the Royal Aeronautical Society, where I am a member of the specialist group for weapon systems and technology. So definitely that's a more aerospace bent. But in our course, we're talking about modern physics, classical physics, that's very basic. We have a lot of quantum mechanics and astrophysics and a lot of lab
Okay.
work as well. So that is
Mm-hmm.
definitely something you would be doing if you take up physics. And
Okay.
yeah.
All right. So we also had this small question box posted up on our Instagram page on Tuesday, if I'm not wrong, and we got quite a lot of questions for you. So I'm gonna ask some questions from there. What are the jobs available after you become, okay, so you already answered this question. Did you ever find the subject dry? If yes, how did you overcome or what did you do to solve it?
I think you will always have phases in life and you will feel whatever you're studying is dry. So I think I was very lucky to have always involved myself in a field like physics, which has so much philosophy to it, which definitely always takes out the dry in any subject. So just go
Uh-huh.
on YouTube, watch some fun videos, watch stuff about how there's advancements in whatever field you're in. Usually I have a few channels on YouTube, not my channels, but like
Okay.
channels I go to
Uh-huh.
watch things about scientific research happening around, which is pretty great, which really makes you realize why you chose to join the stream in the beginning.
Yes, yes. Okay. So someone has asked on the chat box, I'm doing aerospace engineering. I want to know what coding languages I need to know. So you already mentioned MATLAB and Python. And also, what are the basic requirements to get a good job? Right now, I'm at home because college is shut. So you can tell me on what topics I should gain more knowledge.
So depends. Do you want to like study beyond this? Where do you plan to work? And because if you plan to work right after your undergraduate degree, I think there's a lot of competition out there for aerospace engineers. So I think the best way to go about this is you Google whatever organizations you want to affiliate yourself with and see their
Uh-huh.
requirements. I think except the coding skills which I mentioned, you have your degree, and except that you obviously have soft skills like communication, teamwork, etc., which they stress upon. But I feel aerospace engineering also sees a lot of experience which you might already have. So it would be great if right now you could start getting yourself affiliated to organizations which do the same thing, like go join India SEDS, UK SEDS, or any other
Uh-huh.
organizations out there which can help you connect and network with people, definitely.
Of course. Okay. So someone has asked from the Instagram questions, is getting a job in this sector hard to do?
Yes, it is. As a physicist, I feel like if you want to just remain in physics, I feel in India for you to be a lecturer or an academic, it has become harder and harder over the years. But even abroad, right after your PhD, you're never really offered a chance to be a lecturer there. You will have to do postdocs and work years beyond just your final degree ending for you to enter academia. In India, I think a
Right.
postdoc is not a requirement,
Uh-huh.
but aerospace engineering is hard to find a job in India. You should try the US, etc. for this.
Okay. All right.
Oh,
Makes
wait,
sense.
also, like, I think
Uh-huh.
Bangalore and Hyderabad have like a lot of opportunities for aerospace engineers in Boeing, etc. And they hire students from I think first, second year from their undergraduate degrees as well. So you should definitely apply for as many things as you can, because this is such an important thing I want to stress upon. When you want something, keep applying. Do not stop if you don't get something. Like Airbus, Boeing, their recruitment system is very rigorous. but you
Uh-huh.
should still try your hand, apply. Their applications close around December or something, and the internship will definitely be for next year because the current internship applications were last year. So
Yes. Okay, perfect. So someone has asked, do you recommend research in India in the field of astronomy, or are the universities abroad a better choice?
I don't want to thing is, I haven't particularly studied beyond my school in India. So any
Uh-huh.
advice I give based on this will be based on what I've heard from my friends studying in India. I feel you have a lot more choice and to what exactly you wish to specialize, even in astronomy, which is specialized, but there are various more specializations. I feel even if you conduct research in India, for you to find a job in India in astronomy will be slightly hard, but if you have a degree from abroad, for you to get a job there becomes much easier. So if you wish to work
Okay.
in this, it's better if you go abroad.
Okay, makes sense. Someone has asked, can you recommend some colleges for aerospace engineering in India?
I am not very aware of Indian university scenario, but I know that aerospace engineering is offered in a lot of IITs, and I
Uh-huh.
I really don't know about India.
Okay, not an issue. So, okay, someone from the Instagram question box has asked, any extracurricular recommendations to get accepted into any international university?
Okay, so a lot of wait, is this for undergraduate, postgraduate?
I'm sure it's for undergraduate.
Oh, so for undergraduate studies, I feel like the UK doesn't stress too much upon your undergraduate studies as much as it does on your academic bent, and so it's the same for I think Europe, Australia, etc. But for the US, if you want extracurricular, I think extracurriculars is all about what you want to do. Like my extracurriculars were playing the piano and painting, but these were things I was interested in. And when they're talking about extracurriculars, they want to see how far different are you from what your course is. So I don't think there are any extracurriculars which are very aerospace or very theoretical physics like that you can take
Uh-huh.
for your extracurricular admission. It's just whatever you're interested in. I think working at community service is definitely something you need to have, something you need to do, which they really look for. And your extracurriculars, any leadership positions you can take, branch out outside your school in any NGOs you can partner with, etc.
Okay, okay, makes sense. So, someone has asked, okay, 1 second. What is your aim? Okay, you already told us. Do you ever do any practical work since the job is solely based on theory? I think she means since the
Yeah,
degree is solely based on theory.
mm, because it's an undergraduate degree, so our first year was the same as that for um, normal physics students. So we had lab sessions, which were almost 1/5 of our grading for the year. So, oh yeah,
Uh-huh.
we did have a lot of lab work.
Okay, okay, that is wonderful. Someone has asked here on Zoom, can you elaborate on postgrad?
Uh, for uh, like what, the extracurricular bit?
No, I think she's asking about like the universities or say, the fields which are available.
Oh,
Oh,
for
she's asking
extracurricular. Oh,
extracurricular.
okay.
Yeah, go for it. Extracurricular.
Okay. So I was recently looking into this, and I
Mm-hmm.
feel US specifically does stress upon your extracurriculars. Like you can actually go and find like MIT, Stanford, all these universities, what their sample CVs are like, and a lot of them have extracurriculars like people still dance and sing and do community service, but that's not the main thing in their application. It's more research based. They want to see what research experience you have, if you've had research fellowships, you've written papers. That's more of what their concern is. Also, something you didn't have in your undergraduate application was they did not stress on you having work experience, whereas for postgrad application, they definitely stress on you having some work experience. So if you can work in your summer break in the fields that you want to apply in, if it's aerospace engineering, theoretical physics, find jobs, find internships in your summer break, or take a gap year after your studies.
Makes sense. Okay, so someone has asked, since we are here in a STEMM4Girls session, is there any bias in this regard and that you see in your sphere of work? If yes, how distinct is it?
I feel the only bias I've actually noticed is the percentage of women in my classes, be it at school. In school, I had quite a lot of girls in my class because it was a biology class, because there were fewer people taking biology. So people with math as well were in the same class. But in university, I see a very, very small percentage of people taking physics. That has been one bias I've noticed. But other than that, I feel perhaps it's because I've involved myself with so many women in STEM organizations that I have actually seen a lot more female presence out there in this field.
Okay, that is great. Someone has asked, someone has just asked a follow-up for it, which is, what do you think is the foremost reason behind it?
Behind the gender divide?
Behind why is the percentage low? Why do women not take up physics?
I think it stems from like the very basic gender roles that you have, how women were never into very mechanical things, like, you know, the very basic example of how women are given Barbie dolls and men are given like cars, etc. So women were never really so stressed into the whole mechanical aspect of it. Also in India specifically, what I can say is physics has, as if you're just studying based on what you're learning in school, it's not exactly a very exciting field unless you really research or you're doing fun stuff about physics. So I feel that is definitely one of the reasons which dissuades a lot of people from taking physics, because firstly, you do not have the mechanical background because of gender roles and gender conditioning, and then you also don't see the fun side of physics, so a lot of people just don't want to join this field.
Yes, agreed. Someone has asked, are you doing any research right now? If yes, can you explain it in brief?
I'm writing papers, but they're more about like aerospace than theoretical physics, because the kind of research you already have in theoretical physics is so advanced that I don't feel, even if I went ahead to work with any researcher, I don't feel I have the skill set currently to do so. So yeah.
Okay, makes sense. All right. We don't have any other question as of now, but I had someone asked a question. Is it possible to do a minor along with a major in physics?
In the US you can, in UK you can't.
Okay, all right, perfect. I wanted to ask you that you in your write-up itself, it's mentioned that you're a part of so many women in STEM organizations, which is amazing. But my question is that I've heard a lot of people talk about how it gets hard to handle extracurriculars or organizations that you're a part of along with studies. So like, how do you balance it, or do you think it's still doable?
I think definitely I will say you need to enjoy what you do, but that is something everyone says. But I feel I am a very big planning freak. I like to make timetables, stick to timetables, because when I do and I look back a month later and I see the results obtained, it's definitely very gratifying. So I think it's a huge responsibility, because if you choose to do this, you're going to observe so many people around you who are not going to be doing as much work as you would, and then but you will realize how this will give you an edge with time, and you come to accept it. I think it's just about you managing time.
Okay, that is great. All right. Someone has asked, where can we find your papers regarding aerospace?
They're not currently published. I have one of them in it's a UKSEDS symposium, which is going to take place in October, I guess, where I will be presenting one of them, but nothing as of now.
Okay. All right. What is it about? Your research paper? Like, what topic are you
It's
you
about
mentioned
using
aerospace.
space.
Uh-huh.
So it's about using space technologies for advancing, for helping fight climate change.
Oh, wow. That sounds very interesting. Someone has asked, is a minor manageable with physics as a major?
I guess yes, because the number of subjects, like in the US, because if you have to take 10 modules in a year, so you will, if you're taking a minor, then you're not taking up 10 physics subjects plus minor subjects. It's going to be like 8 physics subjects plus 2 minor subjects. So I think it becomes manageable then. But taking it beyond 10 physics modules might be slightly harder. But I do have people on my course who are doing so many more extra modules. So they can definitely, I believe it is manageable if you're into it.
Agreed, agreed. Okay. So I think that was the last question, but since we have quite an eager audience, which is very new, it doesn't happen usually. You just have, like 2, 3 questions, but which is great. I'm glad people are interacting. It's the first time we've had a woman in physics. So as you yourself mentioned, it's really hard to even find a lot of women in physics. So, okay, someone has asked, okay, what kind of scholarships are available for postgraduate in aerospace?
I actually have a list of this, which is on my, it's like a personal list. Like I can open that list up right now.
Of course.
But like depends where you're applying. You have the Commonwealth Scholarship. Wait, let's find it. The Cheving Scholarship, Erasmus, and the uni applications. Okay, yes. So you have the Rhodes Scholarship, Commonwealth Scholarship. You have a lot of them offered by the MHRD in India. The Cheving, Marshall, Erasmus, Castle Smart, the Royal Society, British Council, Charles Wallace Scholarship. Oxford also has a lot of scholarships for Indian students. Then you have them by a lot of universities. So I also feel like if you are applying for just your master's, it's harder for you to find a scholarship. But if you have the master's and PhD program, then firstly, PhD programs are almost always funded abroad, because you would also be doing some teaching assistant work alongside the lecturers. So currently, like when I'm studying, we have a lecturer giving the lecture, and you have PhD students around the class. So if you have any doubts about what the lecturer is saying in a 300 people class, you can ask the PhD student instead of disrupting the entire class. So because you're doing this work, and PhD students are also helping mark your weekly assessments and stuff, so they are paid, and PhDs are usually paid abroad. So masters, obviously you have the scholarship programs that I mentioned and a lot more. And individual universities also offer it, so depending on wherever you're applying.
All right, makes sense. Okay, so we'll wait for another 10 seconds for any other questions, and then we can end this session. I wanted to ask you one question. Is there any specific, okay, someone else also has one, but I'll ask mine first. Is there any specific reason why you chose the UK over US?
I forgot to apply on time.
Oh, okay. But like, other than that, is there any other like strong reason as to why you would feel? Because, when I've asked other people that are say studying in the UK, they mention that the academic rigor is say more than what it is in US universities, which is something, I don't know, like I should ask you, I don't believe in it, but Can you please tell us what do you think?
I feel that is not something I was aware of at the time of applications. But what I've noticed is, like my degree is a 3-year degree, versus if I would be doing this in the US, that would be a 4-year degree. So obviously, the first aspect is you're paying for 4 years instead of 3 years.
Right,
Then a
right.
lot of my friends who are actually studying in the US, they tell me about how you have to compulsorily take more subjects, which might not be physics, because the point of education is not just for you to be employable, it is for you to be a whole person with like a lot of dimensions and facets to what you know of. So a lot of people need to compulsorily take up modules in history, geography, philosophy, etc., English, etc., all these subjects. And when you count the number of modules that you're taking up outside of just your degree, it almost is an entire year of you taking up degrees which are not exactly anything really to do with what you're studying. So if I would be doing physics abroad, I might have to take a lot of modules in environmental science, history, which is great, but not exactly anything to do with physics. So I think because we stress so much on physics, so you would definitely have a lot more academic rigor, and because you can delve into a subject more deeply. And yes, of course, about the assessments in the US versus UK. So in the US, you have around 95%, and in some cases 97% is what counts as an A+ grade. Whereas in the UK, it's a lot of times 70+ is you having a first-class degree. So when I discussed this with an academic at university, they explained to me how for you to score above 70% in the UK means you have studied beyond just your course, because above 70% is stuff which is additional information, which if you know you can solve is great, but that's not part of your course. So you're exceptional if you're scoring beyond that. But in the US, if you're scoring 100%, that means you're very rigorous with your course. So that's why a 70+ in the UK almost always translates to an A+ in the US. So I do feel like there is more academic rigor in the UK.
Okay, all right. So this is going to be our last question. Someone is asking you, recommend some courses as a passed out high schooler in the field of astronomy for the summer.
You can check out edX, Coursera. I know the courses I'm enrolled in currently is this very interesting MIT 1600X course, which is on aerospace and astronomy, which is talking about orbital mechanics and stuff you do in physics in high school. And it also has a lot of very cool stuff about the environmental control systems on the ISS. It's a very interesting course. Any other courses, I think you just need to find any astronomy courses or whatever you're into, like, because it's such a broad field, like I can't suggest a single course. So yeah, that.
Okay, makes sense. Okay, what is the website for orbital mechanics? I don't know what that
it's called edX 1600X
course. Okay, perfect.
Which is on, I think, aerospace engineering, and yeah, it has like a section. So it has like, it's an 8-week course. So one of the weeks is about orbital mechanics, etc. Others are about life control systems on the ISS and interplanetary travel, etc. It's very nice.
All right, that sounds very interesting. Okay, so on this wonderful note, thank you so much for coming as a guest speaker. It was great having you, and I'm glad that there were so many participants